Okay, so to start with vertical asymptotes, it says consider the following function, f of x is equal to 1 over x squared. Now, I'll give you we'll start out with a different function, a little bit more basic, is if f of x is equal to 1 over x minus 3. So remember what we did to get vertical asymptotes? The denominator cannot equal 0. So this denominator here is going to give me a vertical asymptote in this graph. So I'd say x minus 3 can't be equal to 0. What would the vertical asymptote of this graph be? It'd be 3, right? So this graph, x cannot be equal to 3. Therefore, there's a vertical asymptote at x is equal to 3. So this graph, if we were to graph it, at 3, we would have a VA. Okay. For the function that we're going to actually consider, it says, given the function f of x is equal to 1 over x squared, we're going to use limits to determine something to do with vertical asymptotes. So I know that we can never divide by 0. That's why this one had a vertical asymptote at 3. This one right here, though, what can x not be divided by for this one? If you just have x squared on the bottom, what would the x cannot be equal to what number? 0. So this one here, x cannot be equal to 0. Therefore, there's a VA at x is equal to 0. So here's the graph of 1 over x squared, and this would be my vertical asymptote at x is equal to 0. Now, what we're going to figure out is as our graph approaches 0, this graph, if we had our calculator, as it approaches 0 from the left, what's happening is my graph is going up to positive infinity. So how we would write that by looking at this graphically is we would say the limit as x approaches 0, so as my graph approaches 0 from the left-hand side, so I'm going to put limit. So the limit as x approaches 0, the limit as x approaches 0 from the left. Okay, so as we approach the vertical asymptote from the left, our graph is going to be approaching infinity. Then we're going to approach 0 from the right-hand side. As we approach 0 from the right-hand side, that limit is also going to be approaching positive infinity. So the limit as x approaches 0 from the right-hand side, so put a little plus, of f of x is equal to positive infinity. Overall, because as we approach 0 from the left and right, our limit is going to infinity, we could say that the overall limit as x approaches 0 of this function is equal to infinity. The graph as it approaches 0 from both sides is going up to infinity. Graphically, you could look at that and tell. If we were looking at this numerically with a table of values, what you would be doing, so I'll show you how you would do this numerically, and I will give you these numbers since we don't have our calculator. You would be picking, so we're going to be approaching 0, and we're going to be approaching 0 from the left, and we're going to be approaching 0 from the right. So you would first pick a number left of 0, right? So the limit as x approaches 0 from the left-hand side of f of x is equal to. So you'd pick a number left of 0, like 0.1, and you'd plug that into your equation. So you'd plug in 1 over 0.1, sorry, negative 0.1 squared. What you would get if you plug that into your calculator is you would get 100. So this y value would be 100. So when x is 0.1, so really close to 0, y would be way up at 100. Then you'd pick a number even closer to 0, right? You'd pick negative 0.01. So you type in, you'd write first the limit as x approaches 0 from the left of f of x. We're going to get even closer to 0. So we're going to say negative 0.01 squared. And you would get, if you typed that in, 10,000. So now our y value is way up at 10,000. Then if you punched in even closer to 0, you would get a billion for this one. You get a 1 with 9 zeros. So what's happening is from our left-hand side, or left-hand limit, as x approaches 0 from the left, f of x is approaching infinity. If we had calculators, I'd make you do the same thing. I'd make you pick numbers to the right of 0, 0.1, 0.01, and 0.001. Your corresponding y values would be 100, 1,000, and a billion. What's that? Yes, sorry, this would be 10,000 and a billion. So again, as x approaches 0 from the right-hand side, our function, our y values, are approaching infinity. So overall, we say that the limit as x approaches 0 of this function, it is equal to infinity. Now, there's got to be another way that we could do this, right? Because one, I'm not going to be giving you the graph. You're going to be graphing it. Two, we don't have our calculators to do this numerically. So there's got to be a different way to do this. And that's the way that I'll be showing you in this lesson, basically. Okay, before we do that, though, let's just write a couple things for these vertical asymptotes. The function f of x will have a vertical asymptote at the lines x is equal to a if we have any of the following limits. So remember, with vertical asymptotes, we are going to have denominators. Vertical asymptotes we get from our denominators. And if I have x minus a in my denominator, I'm going to have a VA at x is equal to a. Okay, so vertical asymptotes come from the denominator. And remember that it's when, if I have a factor of x minus a in the numerator, that's going to give me a hole in my graph. So it's when we don't have common factors. This would be a vertical asymptote. So for this graph here, you're going to approach a from the left. You're going to approach a from the right. What would the limit as x approaches a of this overall function be? What is the y values approaching for this one? Infinity. So in this graph, if I said to you, what's the limit as x approaches a? From the left, from the right, we're going up to infinity. For this graph here, there's a vertical asymptote. If I said to you, what is the limit as x approaches a of this function? Sarah, what would you say for this one? Negative infinity. Now, we could also have one-sided limits. So for example, I could give you a VA right here, and we'll call that A. And my graph could look like this. Okay, this would be what's called a one-sided limit. I would have to write this as the limit as x approaches a from what side? If this is a from the right-hand side. I've only given you the right-hand side. So it'd be as x approaches a from the right-hand side of f of x, and Akil, what would this be? What would the limit be? Negative infinity. Okay, how do we actually figure this out though when we don't have calculators and we can't graph this on a calculator? So let's look at these two functions here. Y is equal to 1 over x minus 1. So the first thing you have to realize is, okay, there's a vertical asymptote here. So this graph has a vertical asymptote at, and Maya, what would be the equation of the vertical asymptote for this guy? X equals 1. Okay, so let's draw a little tiny sketch. There's a VA when x is equal to 1. So I'm going to put my VA in. Because remember, you'll be sketching these. I need to approach 1 from the left-hand side and from the right-hand side, and I don't have a calculator to punch in numbers. So what will this look like? So we're going to say, okay, we're going to approach 1 from the left-hand side. So we'll say the limit as x approaches 1 the limit as x approaches 1 from the left-hand side of my function, and my function is 1 over x minus 1, is equal to, I have a 1 in my numerator, so I'm going to put 1. And then in my denominator, I'm going to pick a number close to 1, but less than 1. So I'm going to pick 0.9, and I'm going to write 0.9 minus 1. This is equal to 1 over, I don't actually need to know what this number is. I just need you to know if this is a positive number or a negative number. So is this a positive or a negative number? Negative. 1 over a negative number, what that means is the limit as x approaches 1 from the left of f of x is equal to, if I've got basically a positive number up top divided by a negative, that's going to give me negative infinity. So what that means is this graph is going to, from the left-hand side, it's going to approach negative infinity. So now I put an arrowhead down there. Okay, let's see where this graph approaches 1 from the right-hand side. So the limit as x approaches 1 from the right-hand side of this function is equal to, I need to pick a number bigger than 1. So I'm going to pick 1.1. And 1 is a positive number divided by, Alex, would I have a positive number or a negative number down here? I'd have a positive number down here. Again, number doesn't matter as long as you can figure out if it's positive or negative. Do you guys know what this limit's going to approach? It's going to approach positive infinity. So then on this side of the graph, we're going to do this. Now, that's all you need to know for right now. Rational functions, you might remember them from 20-1, but here's what this graph is going to kind of look like. Actually, I'll show you on the calculator. So 1 divided by x minus 1 is this. Now we know here VA, this we can see, and this part we could see. Okay, and then I'll show you how we're going to get the rest sketch later. We just need to know for this lesson when we approach our asymptotes, where is our graph going to be? Okay, this guy here, we need to find what the non-permissible values are, so we need to factor this. Y is equal to x over, Owen, could you factor this for me? 3 and 2, which one's negative? Yep, x minus 3, x plus 2. There's 2 VAs in this graph. Vertical asymptote at, Kayla, what are my 2 VAs? Yep, x is 3 and negative 2. So let's put those 2 VAs in. I've got a vertical asymptote at 3. And I've got a vertical asymptote at negative 2. Okay, so we need to figure out, as my graph approaches negative 2, I'm going to first figure out from the left. So as it approaches negative 2, you guys, my graph is either going to go up like this, it's either going to go to infinity, or as I approach negative 2 from the left, it's going to go down here. We got to figure out which one. Okay, so let's do that to figure out. So I always, and I kind of work left to right. So I'm going to do negative 2 from the left, negative 2 from the right. I'm going to do 3 from the left, 3 from the right. So we say the limit as x approaches negative 2 from the left-hand side of my function. And what I could do is I could just write f of x right now of the function is equal to. I need to pick a number left of negative 2. So what number would I pick probably? Yeah, negative 2.1. Okay, so I'm going to pick negative 2.1. So negative 2.1, I've got to put up here for x. So put negative 2.1 here. That would give me a negative number if I put negative 2.1 here. Then I'm going to put negative 2.1 in this factor. Negative 2.1 minus 3. Do you agree that that would be a negative number? So that guy would be a negative. And negative 2.1 plus 2, Shaywa, what would I have for here? That would be a negative number as well. Will this graph be approaching positive infinity or negative infinity? Yep, because I've got a negative number over a positive number. This graph is going to approach negative infinity. So now I'm going to put that into my graph. So into my graph, I got that going down. As it approaches negative 2 from my left, negative infinity. Okay, let's find the limit as x approaches negative 2 from the right-hand side. So limit as x approaches negative 2 from the right-hand side of f of x. I'm going to pick, Karis, what number? Negative 1.9. Okay, so I'm going to put negative 1.9 in my numerator, and I'm going to have a negative number. I'm going to put negative 1.9 here. It doesn't matter what the number is. I just know that a negative minus a negative is a negative. And what would this one be? Positive. Okay, what is this graph approaching? As we approach negative 2 from the right, where are we going? Positive infinity, Emily, or negative infinity? Yes, because a negative divided by a negative will give you a positive. This will be a positive number, so positive infinity. Now I can go over here, and I'm going to put an arrow going up. Okay, let's approach 3 from the left, and then we're going to approach 3 from the right. So limit as x approaches 3 from the left. So you guys actually put it in, and I'll just pick 2 different people. What is the limit as x approaches 3 from the left? So I'd probably choose 2.9. And the limit as x approaches 3 from the right, choose 3.1 to put into your factored function. Abby, what did you get? The limit as x approaches 3 from the left. Negative infinity is what you should have gotten for this guy. And Shewa, the limit as x approaches 3 from the right-hand side is what? It's positive infinity. Okay, so then what you're going to do is you're going to go up, and you're going to have an arrowhead down here and an arrowhead up here. I'll show you what this graph would look like. This is all you need to know how to do for now, but this is a rational. This guy's going to look like this. This guy will look like this. And then these two have to be connected, and it would connect somehow like that. But that's what the graph would be, okay? Okay, that's vertical asymptotes. So now you know how to figure out, you know vertical asymptotes from 20-1, but now you know where it's going for our graphing unit. Horizontal. Did I have one more that you guys had? I just want to double check, or did I take it out? Oh, I guess I took it out. Okay, horizontal asymptotes. So horizontal asymptotes you did in 30-1. We did review it in limits, but we're going to review it again because we're going to be graphing. So remember, for horizontal asymptotes, we're going to be, okay, here's how we did it in 30-1. In 30-1, we looked at the degree of the top and the degree of the bottom. So for this function here, actually, before we even do the horizontal asymptote, there is a vertical asymptote here. So vertical asymptote at x is equal to, Sarah, what's the VA? Negative what, sorry? Yeah, negative 3/4. So negative 0.75. So there is in this graph a vertical asymptote right here. Okay, now you would have, if this was a test question, you would have said, what is the limit as x approaches negative 3/4 from the left and from the right? So negative 3/4 from the left of our function, and you would have gotten, what's the answer going to be? What is the limit of approaching as we approach it from the left? Negative infinity. Then you would have said, you would have calculated the limit as x approaches negative 3 over 4 from the right of f of x, and you would have gotten positive infinity for this one. And this graph also has a horizontal asymptote. So here's the two ways that we could do horizontal asymptote. From 30-1, we looked at the degrees. The degree of the top is a 0. The degree of the bottom is a degree 1. Top degree is less than bottom degree. Therefore, there's an HA at y. Do you guys remember what the HA is? If top is less than bottom? Yes, y is equal to 0. So right here, there's a horizontal asymptote at y is equal to 0. Now, how did we do this using limits and showing calculus? Because this is how we could just look at a function and say where the HA is. We divided numerator and denominator. Do you remember how we did this from limits? So this will be a good review for the midterm. We divided the numerator and the denominator by the highest power of x from your denominator. Do you guys remember doing this? So we said, okay, the limit as x approaches infinity. So as we get closer and closer to positive infinity of my function, so 1 over 4x plus 3, it's equal to the limit as x approaches infinity. We're going to divide each term by x. So you look at your denominator and the highest degree is in x, so we're going to divide everything by x. So in my numerator, I'm going to have 1, divide that by x, 4x divided by x, plus 3 over x. Then we're going to infinity, or negative infinity, it doesn't matter. But as we go to infinity, what's 1 divided by a really big number? 0. This guy's approaching 0. This is approaching 0. And this would actually, I should maybe rewrite this. As x approaches infinity, sorry, I'm just going to clean this up a bit. 4 plus 3 over x. Okay, so this goes to 0. This goes to 0. So I've got 0 in my numerator, and I've got 4 plus 0 in my denominator. 0 over 4 is 0. So what that means is that's going to be the equation of your horizontal asymptote. So there's a horizontal asymptote at y is equal to 0. So as we approach infinity, plus or minus infinity, I could have actually put positive or negative infinity here. As we approach positive or negative infinity, here we're going to positive infinity, our y's are going to get closer to 0. This side we're going to negative infinity, our y's are getting closer and closer to 0. Okay, let's do this one. Degree of top equals degree on bottom. So let's write that. Top degree equals bottom degree. Where is there an HA? So degree of 2, degree of 2. Do you remember where the HA would be when they're equal? Y is equal to A over B. So when the degree of the top is equal to the degree of the bottom, there's an HA at y is equal to A over B. A is the leading coefficient of the numerator, which would be 1. B is the leading coefficient of the denominator, which would be 3. So this graph has an HA at 1/3. Y is equal to 1/3. There's a horizontal asymptote there. How we're going to show this algebraically is we're going to divide everything by the highest power of x in the denominator. So I'm going to say the limit as x approaches positive or negative infinity of this function, x squared plus 4 over 3x squared minus 2x plus 1, it is equal to, I'm going to divide everything by an x squared. the limit as x approaches positive or negative infinity of x squared over x squared plus 4 over x squared, 3x squared over x squared minus 2x over x squared plus 1 over x squared. The limit as x approaches either positive or negative infinity, I will have 1 plus 4 over x squared over 3 minus 2 over x plus 1 over x squared. As we approach infinity, 4 over a really big number would be 0. So that guy is 0, 0, and 0. The limit is going to approach 1/3, which means that there's a horizontal asymptote as at y is equal to 1/3. As my graph approaches infinity from the right, my y values are going to approach 1/3. As my graph approaches negative infinity from the left, my y values are going to approach 1/3. Okay? What you just need to recall for this is, remember from limits, the limit as x approaches positive or negative infinity, if I gave you 1 over x to the r, and I said that r is greater than 0, okay, what is this limit going to approach? So remember that, let's just say r is a number bigger than 0, so I'm just going to put a 2 here, or a 1. 1 over a big number squared, so 1 over a really big number, is like 1 over infinity. And what does that approach? What's 1 over a really big number? 0, yes. That's just showing, like, why did we say that 4 over x squared goes to 0? Because as we get to infinity, 4 over infinity is 0. That's why we're just putting 0 here. Okay? Okay, here is just a screenshot from your book on page 215. Now, something that's important for horizontal asymptotes that sometimes students kind of have a hard time with is your graph could actually cut through a horizontal asymptote. Your graph will never cut through a VA, but it can cut through an HA. What we care about is what's called end behaviors. So this graph here, if I said to you, what is the limit as x approaches infinity of this function? What I'm asking is, as your graph approaches infinity, is it approaching a horizontal asymptote just as x approaches infinity? And it is, right? As this guy goes to infinity, it is approaching this horizontal asymptote, which is whatever that y value is. They're calling it L. So this is equal to L. Same with this one. If I ask you the limit as x approaches infinity for this one of f of x, I just want you to look at the end behavior. As the graph goes to infinity, is it approaching an HA? It is. The limit. This guy here, the graph is cutting through my horizontal asymptote, which is fine. But what happens is this graph, as it approaches infinity, it's probably going to do something like this, and it will eventually just keep approaching whatever that limit is. So it doesn't matter if it cuts it, it's going to still, as it approaches infinity, approach that limit. This one would be the opposite. As your graph, so the limit as x approaches negative infinity, I want to know what's happening over here on my graph. It is approaching this HA, which is called L. So the limit as x approaches negative infinity of f of x is L. Okay, so it doesn't matter for horizontal asymptotes. Our graphs can cut through. What matters is the end behavior. Okay, degree of top equals degree on bottom. Where is there an HA for this graph? Top degree equals bottom degree. Oh, and where's there an HA? At 3 over 5. So I know that there's going to be a horizontal asymptote at y is equal to 3/5. We'll do just one of these questions using limits. Actually, no, we'll do this one doing limits. Okay, so let's prove it. The limit as x approaches positive or negative infinity of this function is equal to, Julie, I'm going to divide everything by what? Each term by x squared. So 3x squared over x squared minus x over x squared minus 2 over x squared, 5x squared over x squared, 4x over x squared. So we're going to get 3 minus 1 over x minus 2 over x squared, 5 plus 4 over x plus 1 over x squared. We know that all of these will go to 0. And we're going to get 3/5. That's our limit. This one, we won't do the same thing. We would divide everything by x squared, but degree of top is 1, degree of bottom is 2. If we were to use our limits, where would our HA be for this one? 0. So we'll just write that. HA at y is equal to 0. Okay. What I think I'll do is I think I will do slant asymptotes next class. And I will just give you, do I have any? Some homework for this. So for your homework, I just basically need to take out the slant asymptote homework. Um, Should I stop this video for a second?